So, okay. So, hi everyone. Thank you, Grant, and thank you, Hygo Software and IvorySQL for inviting me over. Cedric was too diligently doing the translation as well, so he puts me in a very difficult pressure, right? But you'll see that my slides are very simplistic in their content, so you'll get the idea. So let's start a bit about me. So I come from a data engineering and data analytics background. I started from a business school, but then gradually I shifted towards data engineering for the last few years or so. I've been in this whole process of doing more stuff with Postgres. Beside my, let's say, for-profit work, I also currently a tech lead for the Greek government's incubator for AI, where we're trying to do some of the stuff following the reasoning you'll be seeing here, like simplifying a lot of stuff that happen in the government, but how we do AI, how we do data engineering, and this sort of thing. I come from a Python background, so my first programming language was Java and Python like 10 years ago. So I'm a software engineer at heart. My work is mainly around freelancing. Well, I'm positively surprised that it gets my accent pretty well, I think, right? Yeah, so I do a lot of freelancing in the States and Europe around data engineering in general. And I have to say that I noticed the second big migration. So this was mentioned in the keynotes earlier today as well, that 10 years ago there was the first big wave of migration, which was the process of getting, let's go get everything to the cloud. And I see for the last few years the opposite has been happening as well. Not only for the data hosting, but also for the AI as well, right? So everyone was going, let's pull another AI into the process, let's buy another API key, let's buy another. Suddenly it became expensive and more complicated because complexity the main store. So now we're seeing the second wave. So whatever you'll see here on my slides is these are thoughts and observations out of that process. I'm also author of a few Postgres extensions. I want to mention here the SPAT, which is a really recent one, which touches a bit on the things that Cedric mentioned earlier, in that Postgres has a very extensible API in terms of resources, and this hijacks / abuses / violates the shared memory in Postgres, and it makes it feel a bit like Redis, which is, it's kind of innovative, and I think you should find it useful as well. Also, a recent one is the PG Hiker. I'm not sure how many of you do you at least browse the PG Hikers threads like every few days or so. So you may notice that they can get chatty, and even you can see like patches linking there for like years. So whenever you try, you may find something interesting, but to catch up with everything, it's very, very hard. So PG Hiker it's a very simplistic tool. You basically put it a thread ID from hackers, and it passes through an LLM API and gives you like the key points, the bottlenecks, and so on. It's very interesting if you wanna, get started and see how to do with Postgres and so on. This tool you may have seen, because I know for some reason it became, the reason is wrong, from Pigsty. It became quite popular in China, the PG PDF thing. It's simple as well. You see it in action a bit later in the examples. So I write code, of course, because I have sometimes I have to underline that because people think that, I'm just not writing the code. And in practice, whenever you write code, especially when you're freelancing, you find yourself fighting a lot with operations and their processes. So you have to get this access there and this access there. So if you juggle between a lot of things, eventually you find yourself cultivating a philosophy or so which is minimalistic, right? This, because when you have to switch between different contexts, there are only a handful of tools that you can always trust they are there, like SQL, Bash scripts, Python, and a few others. So it forces yourself to work with a certain mentality. So I want to start my talk here talking about the interface, right? So APIs, the I stands for interface, of course, they're very crucial in programming software, right? So you can think everything is an API. There are a whole lot of quotes there, like you can solve everything with a new API or another level of abstraction and so on and so forth. So whenever you cultivate a certain tool belt of different tools, there are a few. One tool, for example, that is actually there all over the time, right? So SQL, if you think about it, is the best interface we ever had with data, because conceptually and practically connects a lot of different things, right? So what is SQL in it? Since the 70s, really, right? You imagine as an analyst a data table, which a matrix in mathematical terms, right? And you actually describe it, because that's basically what a select query is, right? You say, I want to have this column and that column and so on, and you just push it and show it to the database, and you say, okay, do whatever you want, just give me the end results. So the SQL interface is basically this. You design the reports, the end table, how you're supposed to be, it looks like. You just push it to the database, and the only way to actually get some insight of how the whole thing actually works is if you run an explain plan query, which it's still a bit technical, right? So we don't have really a detailed interface of how that works, but we don't care that much, really, to be honest. So SQL was the best interface so far, in that we found a way to communicate ourselves and connect ourselves with the database, in that what does the SQL parser actually does? It takes a human-like description of a report, it turns it into a parse tree, and then into an execution plan, right? So in the interface there is set-oriented, SQL-oriented or so. But AI actually solves the same problem that SQL tried to solve, really, right? So we force people to say, okay, computers cannot understand natural language, really, but the next best thing probably for us is a parser and a table. So we said people, go learn SQL, and they did. And the companies learned SQL and so on. And then the killer interface was actually AI, right? So you have to say something. It basically solved the same problem with SQL, fundamentally, because you ask for a query even in your same language. So, and it does the whole magic, not only actually the execution plan, but also the reasoning plan, right? So that's from what I see now, and I find myself, and I see others do it as well, is that there is a one-to-one mapping from execution plans to reasoning plans. Because if you think about it, I'm sure there are a lot of power users around here who use LLMs quite in LLM fu, I call it, instead of kung fu, right? Because you can get one prompt, get the result of it, you've noticed that another LLM works better, you push that result there, so you're basically orchestrating a sort of reasoning model, instead of having execution plans between disk and shared buffers and so on. So it's only reasonable for us to think of SQL as a great orchestrator or store. So for the user, it's magic, right? But when you start acting as a data practitioner, as a data engineer, it's not really that magic, right? Because the key point is there, but when you have to deploy things get a bit more complicated, right? So first of all, although there are certain people who say, we have these best practices, this is the way to do it, the dust still hasn't really settled, right? We don't yet have the Postgres, let's say, in the 80s or 90s, or Oracle, who actually said, this is the standard, and now everyone has to refer against that. So you may have not like best practices for different resources, they get outdated quite a bit, quite quickly. So if you see like job postings, you'll see 1 month they mention one LLM framework, the other day they mention another LLM framework, and so on. Every model claims to be the best, but there are certain winners, some cases, but power users I found them, they're more important, the skill set is more important than the model itself many times. And the last point I want to underline is that every LLM framework claims to be the way to do things, right? Which in my experience the last 3 years or so, having tried most of them, they actually overpromise and deliver and complicate things a lot. And I want to stay a bit on this point, because have a look at this and let me know if you spot the irony there. So this is a blog post I wrote a few months back. It went quite popular on Reddit, which is like ORMs in the LLM frameworks are like ORM in the 80s, right? So most of us and you, we are a bit young there, but imagine this story, right? Who has used ORM at least once in their life here? Okay, so a few, right? So probably you may spot a bit the analogy. Suppose you are in the 70s or the 80s, you have discovered this amazing language which is called SQL, which is a much better alternative than Pascal or C, which instead of having to write the whole program like 10,000 lines of code, they sell you that it abstracts away the whole complexity and it just says, forget about it, learn SQL, it's like 10 keywords, and then it translates the execution plan to it, right? And then suddenly a friend says, you know what, forget about SQL. You have this amazing tool which is called Hibernate or ORM or whatever, which does the amazing thing for you, and it translates, you don't have to learn the declarative language. It translates instead everything to object-oriented, right? And then it does the magic for you. Well, ORMs really became popular in the mid-90s. So there is actually a time travel forward. And that's my key point here. It's way too early for us to outsource our knowledge on AI to LLM frameworks. And if you see under the hood and under the pillow what they do very, very basic stuff, which I'll skim through a bit later. So they're actually just a poison without an antidote. They're the poison themselves in a way. Because they're overly confident, right? They say, if you look at LangChain on Llama Index, they have like a documentation of 200 or 300 pages on a PDF. They dictate to do this and that. But if you, let's say, increase your rigor, your confidence, and look at the code, honestly, they do very, very basic stuff that pretty much anyone can do, right? And also, they offer a data by abstraction, in that they create multiple classes. People who have worked in Java, you may have seen this, but it's interesting because they offer a very interesting way to do things, which is, okay, you want a banana? Sure. Start with the Big Bang, create the universe, then the galaxies, then the jungle, then the gorilla, and then you have a banana. So you basically just create a very simple embedding. You have to create very, very complicated stuff. They dictate the process for sure. And the most important thing is they prevent you from learning. They fake you to think that it's very, very sophisticated what they do, when the actual sophistication is into the LLM model itself, not the tooling around it. So my proposal is you avoid and sidetrack this whole tooling, and because it makes you feel stupid as well. So what's the alternative here? No matter the question, SQL is always the answer. This has been true for like 50 or 60 years, and this continues to be the case as well, right? So Stonebreaker publishes a paper every 10 years or so that says, people say the SQL is dead, SQL is back, and so on, and again and again. And during that time, Stonebreaker, like he's in his 90s now, for every wave that happens, he sets up a company, he funds a company, he sells the company, and then again and again we go. So SQL, from my perspective here, is kind of as an orchestrator of things. Remember when I talked a bit earlier about that we had execution plan, we had reasoning plans. Now SQL can actually play the orchestrator, the conductor, let's say in musical terms, in this process. And that you say, okay, I have this pool of LLMs, I can map this into a reasoning plan. So that's the main. To the core of it, if you abstract the whole way of how AI works now, it's all about similarity search, right? So how do LLM models or generally Gen AI, whatever application work nowadays? We have, say, okay, on the one side we have one huge LLM, we have some pieces of information on our databases, we pass some tokens of text, which token of text is the whole secret sauce, which is not secret though because it's completely data and company dependent. So that's the whole juice. We do something, we send it to the LLM model or to the embedding model, we get some scores, and we search for similarity there. So it's basically a similarity search, right? But supposedly people say that we got PG vector, Bruce Mosen said earlier, we got it recently, embeddings, we got it recently. So the process is you get something, you search for it, LLM model, back and forth, and so on. So we talk about tokens, vectors, documents in the very popular LLM documentation nowadays. But does this ring a Postgres bell? If for you, for example, that have you seen Postgres like, I don't know, at least 5 or 10 years ago? It does ring a bell actually, which is this query here, right? Who has used like full text search in Postgres? at some point or so. Yeah, so it's really how this works, right? How does full text search work? We got a few corpora like text, a single vocabulary size, I don't know. In Chinese, maybe they have you have ideograms, so it's a bit different. So, but it's just a longer vocabulary, bigger vocabulary. We assign one token to each word. We get one word, we pass it, and we check whether or not this matches on the text, right? So this has been around for years. It's nothing new. The way this happens is pretty much the same the way this happens today. But instead of having local corpora, we have this big corpora corpus of text lying somewhere server, which we call LLM, right? So AI in practice today, if you start working on it, is like a babushka doll. I didn't want to put a babushka doll here, but you know what babushkas are, right? These are these small Russian dolls. We get one big doll, there's another inside, and so on, right? So this is how I feel AI works now today. So I wonder if someone can guess. So every AI tool today is like a wrapper around the wrapper, around the wrapper, around the wrapper. Can someone guess who the smallest babushka doll is at the core? It's one GitHub package from one Bulgarian guy. It's Llama CPP. Who many of you has or knows of Llama CPP's existence? Yeah, not too many. So, but I'm sure you know Ollama, right? Ollama is more popular, right? The GPT for all is more popular. Yeah, if you speed the logs of Ollama and all these things, under the hood there's basically Llama CPP. There is a work of a couple of people, basically Gary Yerganov from Bulgaria, and a few others, right? Which, by the way, because we're talking about open source and licensing earlier, it's if you want to do like something, an activist move, there is we're recording this, right? Okay, it's good. There is on Ollama on GitHub, there is one issue which is being upvoted, but initially by from Zart from Mozilla and a few others, which basically says, Ollama, you're infringing the MIT license in that you're not, or the license that Llama CPP has, in that you don't explicitly mention the authors of Llama CPP in your code base. So there's this process there. You can go on GitHub and upvote this particular issue there. But the point is, since everyone's GPT for all and all these tools are up around Llama CPP, why don't you can do it directly, right? So that's my whole talking point. You just have to be confident, learn the basics, and do it yourself. So first, what's the most important thing here? Context is everything in LLMs, right? In practical terms, context, we talk about context size, LLMs, and details. In practical terms, context is just picking the interesting data or the substantial data from your database, putting it nicely, and feed it to the LLM. 3 months ago, things like RAG or I don't know, complicated pipelines, how they call it nowadays, they were relevant because models had like 2,000 words of context window. So you had to do some magic, which, sorry, was not really magic really. We just cut and paste from different pages to put up with the minimum 2,000, sorry, the maximum 2,000 words context window. For now, in practical terms, context is actually the art of joining different data. Right, so, and I'm not talking theory here, we're talking about practical stuff, right? So, suppose you're a customer care company or like an e-commerce giant or whatever, the 80% of your job there is to actually pick up the data from your database, like this textual representation here of the product, this country of origin of the customer, these are the key points, throw out all the non-essential stuff, pick up the 80%, and this is the prompt. This is basically what my father does, what my brother does. My father is not that very hardcore at scoring his software skills, but my brother is better in that. He has figured out a way that when he wants to do something, he picks up some details from here, he copy paste it, and he can now build a very nice and effective prompt. Right? Even in business terms, that is the whole substance of the job. Crafting this beautiful prompt, which in practical terms basically joins, right, from different tables, and a lot of string operations. I see people doing stuff with, imagine this, you're an e-commerce shop, you want to create some prompts, you have to create a virtual environment, a Jupyter notebook, pip install, good luck with pip install the different dependencies, set it up, and then do a lot of formatting and templating with strings. There is no way where you cannot do that with the typical SQL format function we have there. So that gets you 90% of the work until there. And the whole thing is that you should push the complexity to the LLM. In that, whenever you find yourself doing something that feels redundant or stupid or naive, take a step back, take a couple of deep breaths, and think that while you're battling with, do I want a semicolon or a colon or an exclamation mark there, you have a 1 terabyte LLM model sitting in there, which, guess what? It will figure out this detail in itself if you're smart enough. Just save your brain cycles for something more substantial. So this is the whole thing of pushing everything in Postgres. And in practical LLM terms, it has a few aspects. I will mention only 2 or 3 of them. The first is you can push even PDFs, right? So I will mention this PGPDF extension I've created, which basically is nothing fancy in its core. It's basically a wrapper around libpoppler, which is a PDF parsing library, which again a lot of tools actually use, a lot of graphical interfaces tools use, but it's just, I added a different spin to it in that you can get a path to a PDF, local or remote, if you have like a mounted file system. You can select and just read the file from disk, parse it through Poppler, and turn it into text. And then you can do your nominal full text search operations and combine this with all the other tools you have. I will also mention that since LLMs work with HTTP via HTTP, you can send a JSON, you get your response back. It's only natural to initiate this response from Postgres as well. Of course, this is not something you shouldn't do with your primary node or even your secondary node. It's probably better to do this with an offline database which doesn't do much operational work because HTTP requests can fail, can be blocking, and so on. So when someone says, okay, send an API key to, an API payload to get something from an LLM, they usually do it with HTTP, right? So why not do it directly from Postgres as well? So you also save yourself from a lot of I/O cycles. And most importantly, production scenario is a more important thing. You don't have data duplication. Because the moment you get your data from one point to another, you have added friction, you've added complexity, you've added just another place that would probably fail your data pipeline. So keeping things in sync, it simplifies a lot of this as well. And then brings me to something which is overreaching on the whole process. What I'm talking about is basically the Unix philosophy, which I'm sure I won't ask. Maybe you have heard of it, but I'm sure the 100% you've bared its fruits, let's say, right? So the Unix philosophy has 3 or 4 elements depending on what you read. The first one is do one thing well. The second one is text is the ideal interface, and then there's another one which is not copy paste. I was lazy enough to copy paste the key points there, but the third point is that you should combine tools, but there's a separate slide for that. I want to sit on the second point, which is text is the ideal interface. With LLMs now, we speak primarily with text, so it's indicating that's still popular enough. SQL is also text oriented. So it only makes sense to pipe tools together. So these are the very sophisticated tools one can use to get you like 80% of the way. Trust me on that. I've done at least a couple of projects who I managed to migrate from Jupyter Hell and Python Hell or whatever and achieve the same results with 1/100th of the lines of code. This plus a makefile to orchestrate those things. I saw an example later. So in case you're not familiar with any of those, curl is basically a very, very powerful tool to get data from point A to B via HTTP, right? So from an API, local API or whatever. JQ is an alternative to JSON path for basic command line processing because all LLM models work with JQ. It's only normal to use them in practice as well. Xargs is a Unix tool which you can use for running commands in sequence, but I'm actually mentioning about the Xarg's parallel execution, which is useful as well, because one thing that you can't really do well with Postgres is parallelize writes on certain long-running queries. So I find myself, scratch that, you don't want to keep too many transactions open for too long. So instead I figured out that instead of doing the whole computation in database, you just parallelize some stuff either locally in your course with Xargs or with GNU Parallel for remote host, and then push the result to Postgres instead. And then a lot of PSQL. I've seen that people don't really appreciate how powerful PSQL, the normal CLI interface for Postgres, can be, especially given how many options it can have in different variables if you pipe it with here docs, I will see later, and so on. I want to see a couple of seconds. There are only 2 slides. This is that have code. I want you to take a look at this. This is from a real life project. It's a free project I've been working on for like 7 or 8 years or so. And this snippet is basically a make file, right? So we get a date range. Notice the PSQL run here. Even for this simple stuff, I've seen people actually install pandas to just generate a very simple series of timestamps, right? So you get this, and if you see this, basically a project that is very JSON oriented, right? So I have a few JSON documents here and there, not a few actually, there are 60 million documents in the Postgres database. You get some different groupings of those whenever they were published, and then for each day I generate one master JSON, which is again a very simple JSON built logic. You can see a couple of joins in there, which they join. I guess you can see a bit. So you'll see that decision is my main table, right? I generate some vectors for a specific model, in our case Gina v3, for example. So mind you, this is also a very easy way for you to have monitoring in the database as well, so you can see how your embedding switch when you switch models or you switch different preprocessing strategies and so on. And then if you see the wild character here, if you run this with make -j/5 or 6, it will on itself parallelize these things. This is a tool that's been around for the 50s or 60s or 70s, I think, GNU make. It can beat everything else you'll see around coming out in the last 10 years or so. So this is, you'll see the logic in here. For those who don't know, the percent symbol here is like a wild character. So whatever this percent it gets, it will put it in here, right? So I will get whatever data I want. I will put in the SQL query and let the database optimizer do the whole thing. And I'll just, after that happens, there's a dependency that I use this beautiful LLM tool from, if you pip install LLM, it is this one. It's from Simon Wilson, a very great guy who is again CLI oriented. And I basically say here, hey Postgres, build this JSON file here, and then to create for each day one separate SQLite database. I don't want to deal with SQLite here. Call this command here, right? It's the simplest CLI operation you can have. So and basically for each day I can have one SQLite database for each day, which because it's still a SQL, right? I can just pipe again into Postgres, but you know, it's a simplicity. You can also share data with SQLite as well, so it's very simple. And then you can look at this. It's basically a here doc in Bash. People don't use it that much nowadays, but it can be very powerful. Take a look at this, and it says basically, I'm hitting this localhost 18434, which is basically the Olama server running. I've installed it, or actually scratch that. No, this is a Llama file running, I think, not even Olama. I basically go to the here doc. I set a kernel timeout. There's a detail for the HTTP extension. I do some string aggregation based on the input that the bash script has, and I set this into an address variable. Think of it as an ID. Details don't matter here. I first run an array aggregator query to get the interesting IDs I want to have, and I just copy paste them literally here into the query. So the address here is this one text here, and then the optimizer itself can use whatever index there is on the table to do the aggregation. So the second stage, and then I turn this into a vector. So you can see the vector operation here, PG vector, and then at the end, after this whole computation has concluded, I just insert this into the table. And if you notice the important last character here is this PSQL, right? So this helps a lot with, because everything now is basically done atomically if you want to, right? So you don't get any inconsistent data or so on. So sounds a bit Chinese, sorry for the pun in this, but if you see at this, it's 4 steps that Llama Index, LangChain, all the other tools, it gets element like 200 or 300 pages of stuff to do this. I know it sounds a bit cocky, maybe it is to some extent. I know it sounds a bit too confident, maybe it is to some extent. But from what I've seen in practice, it's more than enough for a lot of cases. So if you want to screenshot this, do, and it's basically the 4 or 5, it's 1, 2, 3, 4.5 operations that you'll ever need for LLMs to work with Postgres or anything similar. And I think that's it. I hope you found it interesting. Yeah, you can do, yeah. Thank you. Thank you. Thanks a lot. Thanks a lot.